Hey guys, hope you're doing well. So today we'll look at chapter 6 and solve some exercises from these chapters. In general speaking, chapter 6 is about how to apply definite integrals in real life. Not real life, but for example, how to find areas, how to find volumes, and we'll see that it's too easy to find areas, volumes, which is integrals. You know that we had some, we solved exercises finding, and we found areas using rectangles, but we saw that it's so difficult and hard, not maybe difficult, but confusing and time consuming. That's why we have integrals. Okay, so 6.1 is about volumes using cross sections. What that means is if we have, let's say, solid, not solid, but yeah, solid, and we are asked to find volume of that solid, we will find it, we will cut that solid with rectangle, with paper, and when we cut that solid with paper, that cross section, of course, will be, for example, it can be triangle, it can be rectangle, also it can be I don't know, circle maybe sometimes. An area, we'll use area of that circle to find volume. Okay, we know that, of course, area volume is equal to area times height. Okay, and this method, by the way, we call this method slicing. Okay, let's see what we have in here. Okay, you can see here how to find that area. So please look at this section. V approximately equals to sum of VK. What is VK? When we slice this picture in here, like this one, we'll get some areas, and it will be sum of, we'll get some volumes. For example, you see we have also solid in here, and we call it, for example, S1, and we'll have there S2, S3, S4, S5, and Sn, Sn, and volume of this solid will equal to sum of those volumes. And we know that volume is equal to A times delta x key. Delta x is height of that solid, and we know that volume is always equal to, we see that in here, area times height. It's obvious. So this time is clear. Area times height. And you can see in here that it's really high height of this solid, little solid. Okay, so, and Okay, please pay attention to this part. Volume is approximately equals to sum of those VKs. And we put, instead of VK, A times delta X. And A times delta X, like limit of this sum, will give us integral. How we know that? We had, like in chapter 5, we saw that limit of Riemann sum is equal to integral, yes, because and also we had, I think, one exercise. We were supposed to find area using Riemann sum and also using integral, and we saw that in both cases answer is same, but difference is Riemann sum takes a lot of time, but integral is easy to calculate. And this is really important for us. So the volume of a solid of integrable cross-sectional area, of course it should be integrable, otherwise, I mean, how we are supposed to find integral, from x equal a to x equal b is the integral of a from a to b. So volume is equal to integral from a to b, cross-sectional, I mean, we said that we like cut our solid with paper and we'll get this area, and this area, integral of this area will give us volume. Okay, how to calculate? Obviously we have to know that, I mean, first, our first mission is to find that cross section. If you know that cross section, for example, if it's circle, we know what is area of circle, yes, 2p r squared. So it means we have to find just r, and that's it. We'll get area. And find a formula, of course. What does it mean? It means see that cross-sectional area, whether it is rectangle, triangle, or circle. What formula means is like, what is area of, for example, rectangle, and then we have to find limit, then integrate. Okay, for example, I think one of you asked me to explain this one. I think it's example 2. Let's see example 1. We have pyramid, yeah, and height is 3, and we have square base. When we cut this pyramid with paper, cutting with paper is I don't know, it sounds ridiculous, but let's say with knife. We'll see that cross section is rectangle, it's obvious, and the cross section of pyramid perpendicular to the altitude x down from the vertex is a square x. Find the volume. Okay, so we have square. Okay, and its altitude and like distance of its side is x, not distance, but length of our square is x, and height of our pyramid is 3. Yeah. Okay, cool. So what was our first mission? Is to sketch that cross section, to see the that square there. And formula, of course, area of, we said formula means area of that cross section. area of square is x squared, obviously, and y from 0 to 3, because let's see this example in here. Not this one, yeah. So from A to B, A is in here, A is in here, B is in here. So it means height of our solid is our like endpoints. So here we have 0, 1 endpoint, and 3, of course. That's why from 0 to 3 we have to find area, integral of that area, and area is x squared, so x cubed over 3 from 0 to 3, 9. So our volume of this figure is 9. Let's see example 2. We have curved wedge is cut from a circular cylinder form of radius. Okay, r equals to 3. It means this is r. It means we have here 3. Okay. Because this is half circle. And the second plane cross. Okay, we have 2 planes. One plane is perpendicular to the axis of cylinder. One plane perpendicular to axis. Okay. This rectangle in here. And the second plane crossed the first plane at a 45-degree angle at the center of the cylinder, and that is this one. Second one is this. Okay, so we have 2 cross sections. Find the volume. Okay, how we find the volume? When we have circle, we know that what is formula for circle, which like like the equation of a circle where our like with the center 0 0 is x squared plus y squared equals r squared. So x squared in here in this example, x squared plus y squared is equal to r is 3 squared means 9. Okay, and if you find here y, what we get is 9 minus x squared. 9 equals to square root of 9 minus x squared. Okay, we have here plus minus actually, but we won't take minus 1 because distance cannot be minus. And also, like, it can be minus in here, like we have minus coordinates, but y will be, okay, it can be actually. Let me show you. So this point in here and this point, we have plus minus, so this will be minus because it's left side of 0 center, and this point will be plus plus y. It means plus square root of 9 minus x squared. Okay, and when we slice through the wedge by a plane perpendicular to x-axis, we obtain a cross section at x, which is a rectangle of height x whose width extends across of semicircular base. Semicircular base is this one. The area, and we need area of that cross section. Okay, so area, we'll take our area of rectangle, this rectangle in here. Okay, area of rectangle is, we know that from high school, is equal to height times width. Height of our rectangle is x. It was written there. And the width of our rectangle is 2 times this. Why? Because from this point until this point, it's 1 square root of 9 minus x squared, and of course width will be 2 times square root of 9 minus x squared. And then we have to just calculate integral from 0 to 3, and area is just this. But I want to show you again, like I want to go through this question again. Let me delete everything. Because I will take this picture. Yeah. Okay. Okay. So I want you see the clear picture, and I want you to understand this question, because I think in exercises we won't have, it's not difficult but a little bit confusing question. Let's review it again. So what we need is boundaries for our integral. Boundaries for our integral is endpoints of our solid. So it starts here and ends in here. Yes. So, and this point is of course 0, and this point is 3. So it means we'll start from 0 to, and we'll go until 3. So our boundaries is okay, we found them. And what we need also, ax is area of cross section. So area of, we have to find area of this rectangle. How can we find it? Area of this rectangle is, let's say this is a, not a, but it's given that height of this triangle is x. So while this this one and this one, height of our rectangle are parallel, you can see that they are like equal. It means our height is equal to x. Okay, and also area of rectangle, this rectangle, so it's ax. So ax is equal height times width. This, we found that height is x. What is width? How can we find it? So to find this, we can find this point and multiply it by 2, because of course these are same. So v over 2, v over 2. How can we find that point? You know that coordinates of this point we can find coordinates of this point because it will give us distance of y-axis until this point, and of course we'll get half width. But how can we find y? Of course, using circle. We know that equation for circle with center 0. Of course, its center is 0. You can see that. This is, by the way, our radius. X squared plus y squared equals r squared, and r was 3. It was given. X squared plus y squared equals 9. And y is equal to plus minus square root of 9 times minus x squared. Okay, so this point will be minus 1 because it's left side of coordinate, and this point will be positive, so this point will be x and plus square root of 9 minus x squared. Okay, so it means our y is square root of 9 minus x squared. It means width is equal to 2 times. Okay, and that's it. And we'll just put it in here and then evaluate the integral. Okay. Now, let's see what else we have. Solids of revolution, the disk method. What is solid of revolution? We'll have solid like this in this picture, and we'll rotate it by x-axis or by y-axis, doesn't matter. It will be given in exercises. If we rotated this solid by x-axis, we'll get this figure. And this solid, like a solid, I will call it A and B. A, like in solid in A, will be our cross section, like cross section for this solid B. I hope it's clear, like you can see it in here. So we rotate this solid by x-axis. It means we will get something in here and something in B, like around x-axis we'll get this solid, and it means we'll have here a circle, and yeah, and this section we'll use we can use area of that section. And we have a formula for that. You know that if we rotate something by, let me delete, yeah, if we rotate something by x-axis, of course we'll get circle as cross section. And area of cross section is area of circle is PR squared. Now we'll have new formula. It means volume of, again, formula won't change. This won't change, never ever. But as we have circular section, we'll write PR squared. So our mission is again to find area, but if you find radius, then area is ready. Let's see, for example, again this exercise. Y is equal to square root of x. Okay, y means this function, and the x-axis is revolved about the x-axis to generate a solid. Find its volume. Again, formula is rx squared. What is r? R is this point, yes, and this point is, you can see it in here, that if this point is x, means if it's our formula is square root of x. For example, let's say if this point is a, then y will be square root of a, and as we have x in here, then it means our radius will be square root of x, and we'll just evaluate integral, and that's it. Okay, I mean this example also same, it's not difficult. Again, if you don't understand those examples, ask me. What about y-axis? Will be the same, because, for example, if you rotate this solid by y-axis, we'll get same picture in there here, but when we rotate it, we'll get circle again. And now it will be ri squared. It means circle, but on like middle of that circle, middle point of that radius, not middle, but radius will be parallel to the x-axis, and it will, when we rotate it by y-axis, we'll just call it ri, because our x, we won't have x, it's 0 because it's parallel to x-axis. When we rotate it by x-axis, our y is 0, we won't have y coordinate. Okay, now what else we have? But solve the relation, the washer method. Okay, what is washer method? Washer method is sometimes when you rotate solid by, let's say, x-axis, you will have not one radius but two radius. In that case, I mean, you can ask, okay, it's obvious that if we have one radius, pr squared, but what about when we have another radius? Why we have, like, in you may also ask, but how am I supposed to know that when I rotate this solid by x-axis, I will get two radiuses? Yeah, that's a good question, but you should imagine. So you should imagine that when you rotate, when you rotate this by x-axis, you will get this big circle. Like, you will have this. But when you rotate this one, you will get small radius. How can you know that? You know that when we find area, for example, what I mean is when you're forget about volume, when you're asked to find this volume, how you find it? From -2 to 1, from -2 till 1, you just write this function minus this function inside the integral. Yes, it's the same idea. Now again, you see that this function is above this function, then you will just write PR, capital R squared minus little r squared. Now I want to solve exercises. I think you specified some exercises for me to solve, but let me see, what was them? Okay, from 31 till 30. Okay, it started from 31, I think. Do we have something before it? Okay, 17. But I would like to solve one question from each section. Let's see how it will go. Okay, let's solve one exercise about volumes by slicing from 1 till 10. Okay, for example, let's choose, I don't know, 10? No, let's choose 5. Looks interesting. Okay, we have full recap in here. The base of a solid is a region between the curve y equals 2 squared square root of sine x and the interval 0 pi on the x-axis. Okay, the cross sections perpendicular to the x-axis are, so we have to find okay, in A we have to find equilateral triangles with bases running from the x-axis to the curve as shown in the accompanying figure. Okay, we have to find AX, yes. We know how to find area of equilateral triangle, I think. I hope. Let's first find AX. Oops. We said we have to find first AX. AX is equal to 1/2 times like, let's say this side is A. How can I, let me see, can I write it? Yes. No. Okay, I think you know what I mean, like this triangle. This is our triangle, yes. Side of it, let's call A squared times, and as it is, by the way, don't call, like, it's not perpendicular, yeah. as it is equilateral triangle, we can take our degree will be 60, yeah, because and sine 60. Okay, what is A? Let's see graph, by the way. Let me draw a graph. Okay. Yeah, nice. We have here pi. I think our boundaries are obvious. So, what will be this? I mean, what is this distance? I mean, you can see that it's obvious that it's distance from 0 to that point. Oh my god, it's ugly. And how can we find it? Let's say this is x, so that point will be just 2 square root of sine x. So 1 over 2 square root of sine x square times sine 60 is 1 over 2 equals 1 over 4 times 4 sine x. No, it's not 1 over 2, sorry, square root of 3 over 2. So we'll get square root of 3 sine x. Okay, first part is done. Second part was to define boundaries, and we did it. 0, pi, obviously, and then we just have to write volume. Volume was from A to B, ax dx. This is ax, this is A and B. From 0 to pi, ax, this one, square root of 3 sine x dx. This constant, we can write it square root of 3 from 0 to pi sine x dx. Integral of sine x is minus cosine x from 0 to pi equals square root of 3 times minus cosine pi minus cosine, like minus cosine 0 equals square root of 3 times cosine pi is 1 minus plus 1 to the square root of 3. And here's our answer. Let's see B. Squares with bases running from x-axis to the curve. Squares with bases running from x-axis to the curve. Okay. Okay, so what does it mean? It means squares with bases x-axis from curve. X-axis from curve. Again this, but we'll take square there. Yeah, yes. So this side is 2 square root of sine x, and as it is square, it means this side also equal to this. An area of, again, first we have to find area. Is, so ax equal to makes the square of one side 4 sine x. Here's our area. And then what about boundaries? Boundaries again from 0 to pi, and volume will be equal to from 0 to pi ax and ax dx. Ax is 4 sine x dx for 0 to pi sine x dx equals 4 minus cosine x 0 to pi 4 minus cosine pi minus cosine 0 equals 4 minus 1, not minus 1, cosine pi is minus 1 minus 1, 1 plus 1, 8. Voila. Okay, so I think next one was 18. Gunil asked it, I think. 18 from again. Oops. Okay, let's see what we have to find. Find the volume of solid generated by revolving the shaded region about the given axis. Okay, good question. Let's draw a picture. We'll rotate it by y-axis. Okay. We have this. We have okay. Yeah. And we have to rotate it by y-axis. Nice. Means we'll get, when we rotate it by y-axis, we'll get something like this in here, and of course circle. It's ugly circle, but I think you understand what I mean. Same thing in here. Yeah, they should be symmetrical, but it's okay. So x equals to tangent pi over 4 y, and this point is 1, 0. Okay, volume. Our ry, first let's find ry, is of course tangent pi over 4 y. Yes, yes. Now, okay, so I think that's it. Volume is equal to from 0 to 1 r y squared dy. Tangent pi over 4 y dy. Okay, so to find integral of this, we'll use substitution rule. What is substitution rule? So we'll take u equal to pi over 4 dy okay, and let's multiply each side by 4 p dy. Nice. And here our mission is to find u. So not u, but how am I supposed to explain it? Okay, let's for now keep it like that. By the way, oh, we forgot to write squared. Okay. Now, instead of pi over 4 y, instead of this, we'll write u. From 0 to 1, tangent u squared. Not u squared, tangent squared u. du. Oh, we made one mistake. When y is 0, it's obvious that u is equal to pi over 4. Yes. And that's why. Oh, okay. I think we forgot everything, like lots of things in here. Let me write again. What was our formula? I forgot pi. From 0 to 1, pi ry squared dy. Yes, yes, equals 0 to 1, pi, what was our y? Tangent squared pi over 4 y dy. Nice. Now, let me, as pi is constant, we can write pi times 0 to 1 tangent squared pi over 4 y dy. So instead of pi over 4y, we'll write u. And du will be equal to, not du, but yeah, du pi over 4y. Nice. Means that for du equals to pi dy. It means we'll write here u, and instead of pi we'll write okay, so what does it mean? It means, oh, by the way, this is for not dy but du. when we use substitution rule, you also has to be careful about you have to be careful about these boundaries. So our boundaries won't change, but like u will be 0, it's obvious. 0. Y and 1 means u will be pi over 4. So y pi over 4 because u is equal to pi over 4y, and when you put instead of phi 1 you will get this. Means that we'll write instead of pi, of course, 4 from 0 to pi over 4 tangent squared u du equals 4. So how can we do it? Solve this integral from 0 to pi over 4. Let's write instead of tangent squared u secant squared u minus 1 du. Okay, so 4 times integral of secant squared u is tangent u minus integral of 1 is u from 0 to pi over 4. Let's solve it. 4 times tangent pi over 4 minus 0 minus tangent 0 minus 0 equals 4 times tangent pi over 4 is 1 minus, not 0 by the way, pi over 4 minus pi over 4 minus 0. Four times 1 minus pi over 4 equals 4 minus pi. That's it. Okay, so from 31, let's take 31. It's by Suleiman, I think. Yeah. Okay. The region, find the volumes of solids generated by revolving, not 31, okay. Like I will take 33, I think. Maybe you have difficulties. Find the volumes of solids, but I think, okay, let's just solve 31, and if you have questions you will send it. Find the volumes of solid generated by revolving the regions bounded by the lines and curves. Okay, so it's an interesting question, and be careful with these questions. What do we have? X equals 0, y equals minus 1, y equals 1. What you will do is just draw what is given. Okay, let's do it. Draw what you have. What do we have? Y equals minus 1. Where is that? Right here. Gone. Y equals 1. Not gone yet. What 1 is in here, let's say. Okay, y equals 1. Done. X equals 0. Where is x equals 0? Here. Where is square root of y squared? X equals square root of y squared. Let's draw it with green. Not. I say green and click blue, purple, for example. Yeah. Square root of 5y square root of 5y squared will, I think, will be something like this and this. So parabola, but you know, reflected by x-axis, not y. This is y-axis. X equal square root of 5 y squared. Okay. And where is our volume? By the way, oh yeah, our volume is this one. Yes, and this one. Maybe I draw ugly, but you can use GeoGebra to use to see the exact graph. Okay, we have to find these areas. Perfect. Let's find it. How can we find it? We had formula, I think. Our formula was we, like, again, we'll use radius. Volume equals from A to B P R y squared yes by the way, you may ask why you used this formula. When you draw graph, please think like that. When I rotate this area, what will I get? I will get, like, it's not about rotation, by the way, this question, but what I do personally, I rotate this like solid by x-axis, and I see that I will get I will get circle. So that's why I use formulas like this formula. And of course, this line is parallel to x-axis. That's why ry, not rx. Okay, dy. So we have to find ry, and ry is, of course, square root of 5y squared. Okay, equals from where to where? This point is -1, yes. We have to find from this point until this point, so 1. We cannot go below to from this point and upper above from that point. 1 -1 1 pi square root of 5 y squared dy equals pi times from -1 to 1 pi no pi 5 to the power of 4 dy. 5 is also constant. Nice. But I will keep 5. You will know why. So integral of y squared is, I will keep 5 um, y to the power of 5 over 5 from -1 to 1 pi y to the power of 5 from -1 till 1 equals pi times 1 to the power of 5 minus 1 to the power of 5 equals pi times 1 plus 1, because it's -1, 2 pi. And here's answer. That's it. Okay, and from 39 to 44. Okay, which one we can take? I don't know, maybe 41? Okay, let's find the volumes of solids generated by revolving the regions bounded by the lines and curves about the x-axis. Okay, now what do we have? Again, we'll just write it. And we also have axis. Okay. Where is x squared plus 1? It will be, let's say, here's 1, something like this. X plus 3 is, let's say, here's 3, something like this, I think, but no, it's biraz okay. Okay, let's say here's 3. Okay. Where is area? Here. Okay. And from where to where? From here to here. So we have to find their intersection points. How we'll find it? We'll just write so -1, 2. Okay, miss our boundaries. Okay, nice. But oh, wait. Did I think in 31 I said no rotation. Did I say that? If I said it, I'm sorry, because of course it's rotation question. I'm sleepy, so sorry. In this question, we'll have to radius, because if you rotate this function, I mean, think about it. If we rotate this function, you will get bigger, something bigger by x-axis, yes. You will get what you will get, something like this in here, yes. Yes, and when you something smaller is something bigger than this solid, you will get something like this, I think. Yes. Maybe I draw it, it's a bit ugly, but I think you know what I mean. We will get two radiuses. One of them will be for y equals x plus 3, and other one is for x squared plus 1. How will know that which one is bigger? This is a bow, this is bigger. Easy peasy. There was a meme, when you think, it was like, when you think everything is easy peasy lemon squeezy, but you realize that it's actually difficult lemon difficult. I just wanted to say it. I think it's funny. It was 41, yeah. So big capital R X will be, which one is above? This one, yeah, and area is this, so y equals x plus 3 will be our capital Rx, and little one will be x squared plus 1. Okay, so formula 0, not 0, from -1 to 2 pi times r squared x minus r squared x dx equals pi -1 to big R was x plus 3 minus x squared plus 1 dx equals pi times squared dx pi times 2x squared, not x squared, we have 2, let's write x4 minus x squared plus 6x plus 8 pi times x to the power of 5 over 5 minus x to the power of 3 over 3 plus 6x squared over 2 plus 6x plus this plus from -1 to 2. Two to the power of 5, 32 over 5 minus 8 over 3 plus 3. 3 times 4 plus 8 times 6 minus 1 to the power of 5 is minus 1 over 5 minus 1 over 3 plus 3 minus 8. 6 point, I think 4 plus minus plus 5. So minus this and this, pi times so this is 30. I can make, by the way, mechanical mistakes. Sorry about that. So here's our answer. What I can suggest you, it's kind of tip. When you have two functions, you have to know that, like here, you have two functions. You have to know that you will use this formula. But when you have one function, for example, in here, I mean, these are not functions. This is function. Just use this formula. Okay. Do we have something else from 6.1? I think no. Okay. Nothing. So thank you for watching, listening. Have a nice day. Have a good night, maybe. Bye bye. See you.